Hello everyone, my name is Tawfiq from Tenet Technetronics. I'll be giving you a brief introduction on the components that we have. Hello everyone, today I'll be giving you an introduction to a light dependent resistor, or shortly called an LDR, as you can see here. So a light dependent resistor, or it's also called a photoresistor, is a resistor whose value depends upon the incident light intensity. In darkness, the resistance of LDR becomes high, and in daylight, the resistance gets low. So this photoresistor or a light dependent resistor is a light controlled variable resistor. So the resistance of photoresistor decreasing with increasing incident light intensity. In other words, it exhibits a phenomenon called photoconductivity. A photoresistor can be applied in light sensitive detector circuits and light and dark activated switching circuits. So this LDR is a device which changes resistance depending on the light intensity, as I have said. So whenever a light falls on the LDR, the electrons in the valence band are excited and move to the conduction band. So the movement of free electrons and holes causes the current flow in the LDR with decrease in resistance. This current flow may be in microamperes and is not sufficient to glow an LED. So to amplify this current, we will be using a BC547, as I will be showing in a demonstration now. So in daylight, the resistance of an LDR may typically be around 5000 ohms, and in dark it could be more than 2 lakh ohms. So this photoresistor can be found in many consumer items such as camera light meters, or it could be used for street lights, clock radios, alarm devices, night lights, outdoor clocks, solar street lamps, solar radiostats, etc., and for many other applications. So now we'll see a demonstration of how this photoresistor or light dependent resistor works. Now I'll be giving you a demonstration of a light dependent resistor. As you saw the circuit before, so I'll be giving the connection based on that. So for this demonstration, we will be requiring an LDR, that is a light dependent resistor, as you can see here. And then we'll be using a transistor. So for this demonstration, I'll be using a BC547 transistor, as you can see here, a 3-pin transistor. Then I'll be using a 4.7 kilo ohm resistor and 470 ohm resistor, and also I'll be using a 12 volt battery in order to give the power supply. And I'll be using a yellow LED which will blink based on the resistor's value, the photoresistor value. So now we'll just see the connections, how I give it. So initially I'll be connecting the BC547. As you know, BC547 has a 3-pin, you can see here. So this is the collector, the base, and the emitter. So this consists of the collector, and this is the base, and this is the emitter. So I fix this into the breadboard now. I've just fixed the BC547, the transistor. Now I'll be using the photoresistor. So this photoresistor, as you saw in the circuit, is connected to the base of the BC547 transistor. So from there, I'll be giving a 4.7 kilo ohm resistor. So this goes here, and now I connect an LED. So one end of the LED is given to the transistor, that is the negative end, and the positive end is given to the resistor. So from here, one end of the photoresistor is given to the resistor, and the other end is given connected to an LED, and this LED is given to the collector. Now we'll see the emitter part. So this emitter is just directly given to ground. And now here we'll be using the resistor. So from the base of the resistor we'll be giving a 4.7 this 4.7 resistor, and I'll be giving it over here. So as you can see, now this end of this resistor is given to ground. Now I connect the battery and we'll just check how this photoresistor works. So the negative are given to here and the positive will be given. So now we can see the LED blinking. Can you see the LED blinks once I give the power supply? So because the light is blinking here continuously, you can see that the resistor, the photoresistor, allows the power supply from the transistor to pass through this photoresistor, and this LED blinks. So now we'll see how this, you can stop the current flow to this LED. So I just block the light that is supplied to this photoresistor, and we can see this LED just blinks off. So just block the light supply to this photoresistor, and you can see this LED just blinking off. Again, if you supply with the light to this photoresistor, it allows a passage for this voltage 12 volt to pass through this transistor BC547, and it goes to this resistor, now this LED. So I'll just give an light supply, and you can see LED blinking. So this is a small demonstration of how a photoresistor does work. Thank you for watching this video. If you have any doubts or queries, you can log on to www.tenettech.com, or you can drop a mail to info@tenettech.com.